not received yet the final exam schedule. So probably either Monday or Wednesday, the morning. Maybe, I guess, based on my experience, it's probably not 8 to 10. Okay, I think the next period is around 11 or 10 to 11. Till then, the war will start. There might be break time. So between the exam period. So I'm going to check it. Okay, so anyway, so we are going to have the final exam, assign the date. So coverage will be after the midterm exam, so which is not comprehensive exam. So today we are going to continue, hopefully finish the query optimization. Then next week we have a class on Monday, not on Wednesday. Okay. So for your reminder, we are doing query optimization. So the main purpose of the query optimization is to speed up to query the data. The problem is there are so many different paths to access the data. Just like when you make the plan for your travel during the Thanksgiving holiday, so there are a bunch of different ways. So you should have the criteria when you decide the final plan. So only one plan you can use, right? Even though you have the multiple options, one time you can use only one plan. Similarly, query optimizer will decide the one best plan, then give the execution plan to the query processor. Then the query processor will access the data by following the plan. But at that time, what is our criteria from the database point of view? So it's
Make it faster.
yeah, faster. So it's a few I/O. So that is our criteria. Okay. So we are going to count the number of I/O because the disk I/O is the most dominant factor. So among the bunch of different resources, so we have the burst latency or the memory I/O and a bunch of other resources. But comparing to the disk I/O, we can ignore. To simplify the process, we are going to count such a number of I/O. So first, there are two main things. So when we consider the query process, one is the access the table. Okay, one table. When I'm saying the access the table, one table, just like the when you travel, sightseeing for the city. So there might be the way. So last class, so we please use your handout. Otherwise, I'm going to use this one. So there are different ways to access the one table. Okay, so first approach, always we have the root first. The root first sometimes is called the full table scan, or sometimes it's called the linear search. Doesn't matter, whatever that. So then the for each case, we are going to calculate the cost. So eventually, there are two types of optimizer. One is rule-based. Rule-based is we have just criteria. The first option is always cheapest one. Then next is a shorter time, like that. It doesn't matter how much it costs or how long it takes. We have the certain rule. So we select this option that satisfies with the first rule. So like that. In case of a database, the first option is primary key. If you can use the primary key, please use the primary key. Whether or not that is really fast, so we are going to use the primary key like that. Okay. On the other hand, the cost-based optimizer always calculate the cost. So for example, the linear search, so let's say the cost of the S1 is we are going to count number of I/O. I/O means number of blocks, right? So we are going to count it. So I'm not going to go over again, so you can see the notation of the variable. For example, R is the number of records, which are not much that we are interested in. So, but we are interested in number of blocks, E. Okay? So, for example, the table. In this table, we have like the number of block. Okay, these are the number of block B. So when we calculate the cost to access this table, okay, so we are going, when we are using the brute force or full table scan or the linear search, how long it takes? So B, but on average is 2. Okay. However, if your query is like the inequality, okay, social security number is bigger than the 1,0,0,0,0,0 something like that, then at that time the cost will be the B, because anyway, because it's not sorted, we need to access all the table already. Okay, so but most of the case, in equality case, so it's a B over 2. So if you are lucky, so you can find the first, otherwise it's the last. So on average, it's a B over 2. Okay. So second option. So the first option will be used every time. So brute force will be the option every time. So the second option is, in case this table is unordered by the specific column, like for the social security number is ordered by the social security number. Okay, in case it's the ordered file, ordered table, we are able to use a binary search. So second option is a binary search. Binary search cannot be used every time. Only in case table is sorted order. Okay, at that time, if we calculate the cost for the binary search, it will be, as you know, log B is on 2. It's a binary search. Okay, then not this one, because even though this one is ordered, what if this is ordered file? So we can find the specific column for the social security number. In case of a social security number, the selectivity, selection cardinality, which means for the one value, how many record is 1. Okay? We can stop here. When you find the specific record, you can stop here. However, if this one is for the DNO, it's ordered by the DNO. It's sorted by the DNO. When you find the specific record, okay, starting with it's a 3, then we have more 3. Next block, right? So at that time, so we need to access how many records. This amount of record, that is selection cardinality. S is the selection cardinality. How many values? How many records for this value? Okay, so selection cardinality, this is ordered, so we don't have to access record by record. Instead, one block, another block, another block. Okay, so it's divided by buffering factor. Then always, when you count, you need to see. Okay, even though one record, entire block should be accessed. In this case, this one, the first block is counted 2 times, right? When you search the first block using binary search, the 1, and also when you search through this one, so it's counted 2 times. So we can minus 1. Okay, so this is the cost function when you are using binary search. Okay. However, if the selection cardinality of the key is the 1, like for example social security number, so this one will be 1. So 1 over something is 1 minus 1. So in special case, it will be log 2b when selection cardinality is 1. Mostly this one is unique. The unique case. Okay? Don't be confused. So far we don't consider any index yet. Only access the file. So this one is non-ordered and this one is ordered. This one is ordered by the unique key, and this one is ordered by non-unique. Okay? Clustering. We will see the clustering. Okay, so that is the binary search. Then the third case is the primary index. when we have the primary index. What is a primary index? So primary index is this is the order. Okay? We are going to create the index for order the key. Okay? So then we have the one for each the block, and this one like that. So this is the primary index. So when you access the data, so first you need to identify the key entry. How can you find this specific key entry? Using this one is automatic. Any index, they are ordered. Okay? Which means we can use binary search. Always find the binary search. So it will be low. Listen to. For what? Number of index block. Okay? Number of index block. Then, so when you find the index key entry, this one has a pointer. Pointer to specific the data block. So first, you can find the index key entry, that is the cost IO plus 1 more IO is to access the data. So for example, in case of a primary index, if this one is multi-level index, so multi-level index means index of index and another index block. So in this case, like this, and like this, finally this one. How many? Is the level, because this one from the level X, the tree structure, search tree. Okay, so 1, 2, 3 plus 1. So that is the reason in case of primary index, the cost of the S3 is X plus 1. In this case, X is the level of index. Okay. Any questions so far? So pretty much it's straightforward. Well, there's another one is a hash key, but hash key is different. So as I said, so there is another one is so hash. So in case of hash, so table structure is we have number of what? Hash bucket. It depends on hash key. So we have the hash bucket. So we are going to store the data into each hash bucket. One hash bucket may have a number of the block. Okay? So we cannot actually exactly count how many blocks. It's actually narrowed down the roughly. We are going to count the entire number of blocks for the table, then divide by the distinct hash value. Okay, like if you are using the modular, the 5. So we have how many? 1, 2, 3, 4, 5 hash bucket. So if your data file has 100 blocks, like the B is equal to 100 divided by 5, so 20, like that. Then search entire. So however, most of cases the term modular hash key will be a lot. So we can narrow down. So to simplify, in this example, we specify just one, but we are not going to consider the hash table for our example. Then the next one is the primary index for what? So primary index with a multiple record. So for example, so if this one is the DNO, the primary number of blocks in here. So if this one has the pointer of the grouping like the 1, 2, 3, so 1, 2, 3, okay? So it's not unique, so it's a primary index. Further, this one is a primary index but multiple the record. At that time, using index 1, 2, 3, so we can find, and we can go to the what? The multiple time. How many times? Primary index. Okay. So B over. Oh no, I'm sorry, I got confused. So this is the same as the primary index, like the social security number. But the query is like that. Select from employee where SSN is bigger than 1000000, like that. Okay? Then we can change it into the number. Okay? Which means it's still there, but once we find the index, like the 1000000, then all after that it will be accessed, right? Because it's the order, the primary index. So at that time, if this SN, the value is the last one, you can access only one data block, right? However, if that is the first one, you need to access all entire block, right? Because it's an inequality. So at that time, on average, to access the data file, it will be B over 2. So in case, so it's the same thing, primary index. So we need to access the level 1, 2, 3. Then the plus, how many block? Not just one block. You should access B over 2 block. Always number of block will be same. So that is the multiple index. So in other words, it's the inequality. This one is equality, the condition. Okay, so that is the primary index, multiple record. So using the inequality, the condition. Okay, the next one is the clustering index. Clustering index is a grouping like the DNO. Okay, so clustering index is we can access. What's the function of this one is we are going to access the level X, then it has number of record, right? So number of record, but we are going to, that is the S, selection cardinality. So for each DNO is equal to 1, has a 20. DNO is equal to 2, is a 30%, 30 record like that. So we have such the information that is a selection cardinality, but we need number of block divided by blocking factor. So that is the S divided by the blocking factor. That is the number of block of your table. Okay, so that is the clustering index. So this one is for the table only. This one is the primary index. This one is based on the clustering index. The next one is secondary index, which is the most popular one. So secondary index is a 6. So it's a secondary index. Most of secondary index is the same as we are going to consider B plus 3 index. Okay. Secondary index means we are going to index for non-ordered column, any attribute. At that time, so we are going to use the B plus 3 index here. Then, so in case of the equality condition, of course the function of the equality condition is, so let's say this is the B plus 3 index. B plus 3 index, we are going to access always from the top and next and until the leaf node. Okay? Then 1, 2, 3, then access the data file. So that is the X plus, if that, for example, select from employee there. Let's say this one is indexed by the DNO. So DNO is equal to 1. So DNO is equal to 1 is several the block, number of block. What? How many? It's a selection cardinality S. So we are going to access how many time? S time, right? So this one has the DNO is equal to 1. One has the block, the address here and here and here, depending on how many the record, how many record of the employee with the DNO is equal to 1. It's a selection cardinality S. So we are going to access this much the IO to access the data file. So that is the reason it's the X plus S. However, there is the general case inequality. And for example, let's say the DNO bigger than 1. So using B plus 3, you need to find the DNO is equal to 1, right? Then this one has the pointer for this. And also, this one is the inequality. Inequality means 2, 3, 4, 5. 2, 3, 4, 5 till the end. Because one of the characteristics of the B plus 3 has a sibling pointer. So using sibling pointer, you can access the next index block, next index block, next index block. So to calculate the cost function, C as 2 is the first level. You need to access this much. Then, how many index block? It's on average. Sometimes it's one index block. Sometimes all the index, the block. On average, it's the half. Okay? So, there is the value like the BL1. BL1 is the number of first level, leaf node index block. So this BL1 is the number of this block. So we are going to access half of them. Okay? So that is the BL, the 1 is and the half. Always the block is the ceiling function. Then using this one, we are going to access the data block. So data block is how many? Because it's a range query, it's an inequality query. So if we count all of this, sometimes it may be one record, sometimes all record. So on average, you need to access the R divided by the 2 times of the block. Block is always this one. Okay, so which means it looks like much bigger than this, much bigger than equality. So which means when you are using the inequality, using index will be expensive because of this kind of reason. So index is not always the fastest way, depending on your query. So we will see the more index. So one more time. When you are using the B plus 3, the secondary index is not data file, it's not sorted. But we have the level of index using the B plus 3, the algorithm. So in case of equality, we are going to access the index X level. Then depending on how many values, how many records for the index value, so we are going to access the S time. So X plus S, selection cardinal. In case of inequality range query, so we need to access X much, the X times of the index block level. Then this one is the how many index block. On average, half of the leaf block. So half of the leaf block. Then because it's a half of the leaf block, so we are going to eventually half of the record on average. Sometimes maybe 0 or 1. Sometimes all the blocks you need to access. So this is R over 2. The block is always the 3. Okay. Then the next one is S7 and S8 is what if the query is like the N. SSN is equal to 10000 like that. And so like the salary is the like this. So this one DNO is also index. So SSN is index. Salary is index. This time is called the conjunctive, the condition. So you can calculate the cost for this. You can decompose the query and calculate the cost for using SSN. Calculate the cost function for salary. Then you can select among them the lowest one. Okay? So in case of conjunctive, you can decompose, divide, split the condition, then using one of S through S3. Okay, you can use one of S1 through S3. That is the conjunctive case. Okay, so based on that, so this is the further example. So we will see the example of using S1 through the S6. Let's take a look at the example of the employee file, employee data file. So we have total 10,000 employee record. Okay. Then how many block? It's a 2,000 block, which means what is the blocking factor? It's on average 5. It's the number of record divided by the block. It's each block has the 5 record. So this is the given information. It's in catalog database. Then, so regarding to the index, the employee table has the clustering index on salary. Clustering index on salary. Then, how many level? It has a 3 level. And the cardinality. Cardinality means it's a, if you take a look at the selection cardinality, is the how many record for each value. On average, it's a 20. So which means salary 10,000. How many employee? On average 20. Okay? Specific salary value, so on average 20. The first 20 employees. That is a selection cardinality. We have another secondary index. Secondary index is the B plus 3 index on SSN. How many level? 4 level. And the selection cardinality is 20. I don't think so it's 20. It's 1. Okay? It's a mistake. So it's already 1. But this one is a whole.
Yeah, this one also doesn't have the select function.
Oh, really? Because I think I do not make the PDF file. Okay, I'm going to update. So this one is the correct one. So SSN is the unit. Okay, so which means selection cardinality is just 1. Okay. Then secondary, we have a third index is the secondary index. Secondary index means B plus 3 index for DNO. So level is 2. Level is 2. And the first level, the block, which means the leaf block, is the total 4. The leaf will is like this one. So DNO, we have root. I'm not sure like this. So total 3 levels of internal and the leaf level, leaf node, terminal node, and how many blocks? 1, 2, 3, 4. So this is a B plus 3 for the DNO. Okay. The distinct value is 125 means total 125 department. Then which means how many the record, how many employees per the department. It's 10,000 divided by 125 department. On average, that is the 80. Okay, so selection cardinality is 80. Then we have another B plus 3 index on sex. How many different? In this case, the 2, but nowadays it may be more. So, but let's say the 2, so male or female, then so level is 1 because it's only just 2, the different value. So selection cardinality is 5,000 and 5,000 on average, not exact value. It doesn't have to be the exact value, it's on average. So this is our information. So, yes?
The third one, level of DNO is 2, right?
Yeah, its level is O, which means the index will be 1 internal load and it's like that. More specifically, it will be like this. And this one is a sibling point. So level 2, or the 2 point. So my mistake. So in the third case, secondary index on the non-key attribute DNO. So this one is a level 2, the internal and the leaf node. And the first level node, the block is the 1, 2, 3, 4, 4 block, and then this one. Okay. Then where does such an information so DBMS use what to keep such information? Catalog database and metadata. So metadata is in other words the catalog database. So what is the form of such a catalog database? Also table. Okay. So we are going to create such a table. So first table is the table information, relation information. So let's say the REL underscore info. So attribute is the table name and the number of record, blocking factor, and number of block. So there are 2 entries, 2 records for this table. So employee has the 10,000, 5 the blocking factor, and 2,000 the number of block. Department has the 125 record and 10 per block, and total the 13 the blocks like that. Who manages such information? User? User doesn't have to. Administrator. Administrator keep updating such information. So sometimes the DBMS provide automatic. The manage such the catalog information. Sometimes the manually the update. Keep updating such information. So it is very critical in the real life system to update. The problem is, so to check, how can you check the number of records? You need to read the data. So it takes a time. It's overhead. So many of the system, DBMS use sampling. Okay, not exact value, it's a sampling. Just like when the Google access the data, I don't think Google can access the entire travel agent information, everything. Okay, as much as possible. Then using big data solution, they can provide the average, the value or maximum value and the lowest value, and suggest the lowest value fair, like that. Okay, but when you enter the really that website, sometimes cheaper or the expensive, because it's not 100% guaranteed consistent the accurate value. Instead, the last the update the data like that. This doesn't have to be the exact value. Instead, it's based on the statistics. We can the DBMS provide the reasonable. Okay. Also, for example, if the department information will not be changed once a year or the couple of times, so you don't have to update every time such a data. Employee maybe the weekly, but the transaction information every day like that. So the administrator need to update such information based on the characteristic of the data. Similarly, we can create another catalog table for index. So this is an example of the index, the underscore the info. So first column is index name and the table name, attribute name, index type, and the level of index. And this is a selection cardinality, average record per value. And in case of the secondary index, how many? First level block, leaf node block, and the distinct block. So let's see the example. So this one is a cluster index, and the others three are the B plus 3 index, secondary index. So this is the primary index for the department, and this is a secondary index. Let's take a look at the example of the SSN. SSN is the secondary index, and the total level of index is 4, and the selection cardinality is 1, and the leaf node block is 10. Okay, I don't think this one is updated. I think the pre-now.
It's right on here for that part.
Yeah, so I'm going to update. Okay, I'm going to update the canvas. So for example, the level is 10, and distinctive value is 10,000. Also similarly, Diana is not the unique, so it has the 80. The on average selection cardinality, and the leaf node block is 4, and so on. So you can see the index for the sex. We have the two distinct values. Selection cardinality is really high, 5,000 for each female or male. And then the level is just 1, okay? Because it's the two distinct values. In case of the DNO, department, the primary index, we have that it's not the B plus range index, it's the primary index. So it's ordered by the DNO. So we can create the index based on that. It's a sparse index. And also there is another secondary index using manager social security number. Level is 2, and the selection cardinality is 1. So we will see the drawing information later. Then using this information, so we are going to finally optimize. In other words, find the best value, best root. So let's say the first example is select from employee where SSN is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So suppose that you just submit this query to the client, so MySQL. What happened when a user submits this query? Scanning, parsing, validating is the interpret. So client module interpret this one and make the binary code of this. Then the query process the decompose by the block. So which means the one select from where. This is one SQL block, then generate what? Relational algebra expression. For example, in this case, so SSN is equal to 1 to 9 plus employee. So query process make the one SQL block, then create the relational algebra expression. So from here, the query processor check. So what kind of option among the S1, S2, S3, S7, and 8, what option can be used? Always, as I said, S1 can be used. So S1 is what? Brute force way. Okay? Brute force full table scan is always the option. So, in case of check another option. The SSN is indexed. How do we know? So using the employee information, so if we go to the index underscore info table, employee, then SSN is indexed. It's a secondary index. Okay? So which means we are able to use this is also equality. We know this is equality, which means we are able to use this option. Right? So S1 can be used, and S6, the 1 can be used. There's no more options. So there are two different cases, two options to access employee table. One is brute force S1, another one is S6, the -1, that is based on the B plus 3 on what? The SSN. How can we decide? query process take a look at the relation as range. Of course, in the condition, only SSN. Okay? So we cannot use this option because it's not primary index. There is no primary index used in this. Okay? Only based on the query, we can select the two options. So, what about the brute force? Brute force is the B over 2. So, how many blocks does the employee have? So, how do you know? Access this catalog table. So, if we take a look at the catalog table, how many blocks? 2,000. So 2,000 divided by 2, so 1,000 block. This is of course when we use the full table scan. What about this one? So it's x plus s. How many x? How do we know? What is the x? So always catalog table. So if you go to the catalog table, so x, the SSN, this one, x is 4. So this is 4. Plus, what is the selection cardinality? 1. So this will be 5. So, 1,000 and 5. Which one will be selected? Which option?
Second option.
Second option. So query optimizer select this one. Then, what is the output of query optimizer? The query optimizer create execution plan. So access employ using what? SI underscore SSN. This is the final output. Then send back this execution plan to whom? Query processor. So query processor use this information, then access the data file, using this one, then access the employee and return the data to the client. Okay, so that is the final one cycle of your query. Okay. Similarly, next, any question for this? I'm going to simplify. Then we have the join operation also. So one more example. So DNO is bigger than 5, which means let's slightly change the query. Like the DNO is bigger than 5. It's inequality. So at this time, we can query optimizer change the relation algebra is bigger than 5. It's not SSN. This is the DNO. It's bigger than 5. Then we need to decide always. This is the option. This is the option E over 2. Or B. Which one will be used? E over 2, B.
B by 2.
If this one is odd,
It's an inequality.
yeah. If this one is ordered by the DNO, it will take the B over 2, right? Because it's ordered by the DNO. However, it's not. Okay? There's no mention about the primary index. So if you see this information, this one is ordered by DNO, DPT. But the employee table, there is no such a dimension, which means it's random. So always you need to access all of them. You don't know where is specific value. Especially this one is bigger. Okay? So we need to access 2,000. The 2,000 the block. Is it 2,000? How many blocks? Yes, 2,000 blocks. Then second option is any other options? So this one is the DNO. So DNO, we cannot use the binary search. We cannot use the primary index. We cannot use this one. So we can use DNO is the SIDNO. It's a secondary index. Okay, so we can use this index. So which means S6. But this, in this case, this is an inequality. So we need to use this option. So x plus the leaf node blocking factor and plus. Okay, so what is the level of index? Level of index is 2. Plus, how many leaf node block? It's a 4. It's not blocking factor. It's already the block. So on average, it's a 2. Because we need to access, when you find the specific leaf node, then all the other, because it's bigger than 5, right? Bigger than 5. So if you are lucky, it's the last one, only one. If you are not lucky, it's the first one, all the other. So on average, it's a 2. Then, how many record total? You need to, so we have the index, then we need to access. Using the data pointer, we need to access all of this. How many? It's a 10. How many blocks we need? This one is R. R means it's a total record. So 10,000 divided by the 2. Okay? So 5,000, this one is 2, so 4. So 5,004 IO we need. Okay? So 5,004 IO we need. So then, which one will be selected? This one or this one? So S1 will be selected. So output of this execution plan is access employee using the what is the index name? SI underscore TN. So this one will be sent to the query processor. So query processor will process the access the data, then return to user. Quickly go over the DNO is equal to 5. So DNO is equal to 5. We can use this one. The selection cardinality is 80. So 80, so plus 2, so it's 82. Okay. What about the option 4? So option 4 is like this. Where the DNO is equal to 5 and salary is bigger than 30K and sex is the female. So we have the conjunctive, the query. So conjunctive means it's a combination of the different selection. So instead of the select from where this, select from where this, so we can consider the one case, okay, DNO. So search, we already did, the DNO is equal to 5. So how much is the 82? So this one is 82 already, we did. And using salary, you can use, salary is indexed, right? Salary is not indexed here. So you cannot, salary is indexed, the first one. It's a cluster index. So you can use the cluster index, the cost function. How much is that? If you calculate that one, it's 5,000, the 1,003. This one is 1,003. Then this one is also indexed by what? It's a binary, the B plus 3 index. So with one node and distinct value is 5,000. So if you calculate that, apply this one, so it's 5,001. Okay, so we have this the cost. So which one will be selected? And also plus what? Root first. We need to use the brute force is 1,000. So which one will you select? In this case, is the up. We have inequality salary, so it should be 2,000. So salary is inequality, so we need to access the entire block. So 2,000. Then what is the? Which one will be selected? 82,003, 5,001, and 2,000. So using DNO is the lowest cost. So query optimizer will return excess employee using SI underscore the DNO. SI underscore DNO. This is the execution plan. So in case of conjunctive, so you can divide the condition and find all the cost function and select the lowest one. Yes?
For salary, it
Yes.
says it is the cluster index type.
Mhm.
Why aren't we using clustering index S5?
So salary is, let's go back to here. So salary is the cluster index. So cluster index, then the cluster index is this one. So level is 3, then the selection cardinality is 20, and the buffering factor is 5. It's a 5, right? 4 or 5?
5.
5. So it's should be 7. Why is it 1,003?
Because you use S4.
If this one is true, I think this one is wrong. It should be S, right? This one should be S. S divided by buffering factor. Then this one. But the problem is, this one is bigger than 30K, okay? So bigger than 30K, so we are going to use, if we see the let's the credit for I think this one should be primary. So that is what I expected from that. So this one is the primary. But let's use that this one is the cluster. Okay? So this one is the cluster, and then we can use this one actually inequality condition, so which means we need to access when we find the specific location, then we didn't actually calculate the inequality of the clustering. Think about the cluster index. This is table, so we have the cluster index, the DNO. So when you find, and we need to access all of this, okay, for each of them, not the one. So that means, so on average, we need to access entire block. So rest of the half of the. Oh, I see. So this is an inequality, right? So after we find the block, this is the after all of this. Okay? On average, this is a half of the block, right? So we didn't calculate the cost of the clustering index for the inequality case. So in this case, so clustering index, this is the equality case, right? So if we find the space block, then all of these are the block that is will be returned. And if there is another, because it's a selection cardinality, so then all of this. Then for each case, we need to, so this one is for the rest of this, right? For the index. And then this one will be for the rest of this, which means instead of accessing all this one, first find this, then all of this. Then on average, how many of them? Half of the block. Okay? Then let me clarify one more time. This is correct. So I think I remind. So it's the same question before. So I did the last semester. So this one is so salary is bigger than 30K. The salary is a clustering index. So in case of clustering index, we have the salary is 3,000 has the how many on average? 20 employed. Okay, 20 employed, then 20. You need to access this one. Okay, then the salary is bigger than this. So we are going to access on average half of this. No, not this one. Access this one. Then because this one is the salary is the 30. So bigger than 30. So first find the salary, then the half. This one should be the not half. I think the last time it was the same question, I remember. So then this one should be primary index. Then it's makes sense. Let's change it the primary index. I think that was the problem. So let's then change it the primary index. Then if this one is the primary index is sorted by the salary, then we can find the 3,000. Then after that, okay. So it's on average there is a half of the. Then we can use the primary index. So we can use the primary index. We can use this one, the multiple. Okay. I think this is not clear, the salary part. I'm going to clarify, to update this one. Okay. Then we have the 1,003 and the 82, 2,005 and 1,001. So we can select the DNO to access this query. Okay. Let me clarify this, then update. Okay, the next join. So first we have two tables, R and S. So think about how can we join the two tables? We are going to find common information, right? Common data for the joined column. So which means, so first think about we have the one group of person. I mentioned about the experience on during my military service. So for interview to match the parent and student. So we have the parent, and another room we have the student. Okay. So one way is we are going to ask the parents. Then what is the student number? Then we can go to the next room and call the student number. Then find and match. That is one of the way. Or If you do not know the student number, then call the one parent. Then check each and every student whether this is the child or not. Okay? Until you find your child. So at this time, so let's say the R is the parent table, and this one is the student table, R and S. Then, if you go to the one table first, like the parent table, this is called the driving table. Okay, and then find the next one. This one is called the driven table. So driving table first, and then driven table. Or sometimes it is called the outer table, and this one is inner table. Okay? Then, how can you find for each parent until you find your child, which is the join condition? Until this condition is satisfied, you need to check the all driven table. Then next, and next. So this approach is called the first join. This one is called brute force. Okay, so brute force way. So it's called the nested loop join. Brute force way and nested loop join. So this one, nested loop join, is very popular in the programming also. For loop inside the for loop. So like the for the I and the for j. So for each I, you can match each of the j, the inner loop. So this is called the brute force way and also nested loop join. Okay. Then if condition is satisfied, and return this one and this one, then save in the memory. So this one and this one will be stored at the memory and later return to the user. So this is called the nested loop join. Another join is what if if you know your student number, you can just call student number. Then you can find. You don't have to search all the student, instead directly find using index. If the student number is known, then you can directly use. That is the index. In case S is indexed by the condition, then you can use such an index. You don't have to receive all of this. Instead, just one time, one time, one time, one time, one time. How many times of loop? One time of loop for the driving table or outer table. So this one is called the single loop join. So which one is faster? Nested loop join or single loop join? Definitely single loop join. When you have index for the driven table. If you know your student name, so this one will be faster. However, if you do not know the student number, or if you do not have the index of the driven table, inner table, so no way to use this one. In case the index. Then third one is before join. You do not have an index. Neither of them you have an index. Sort by the joined key. And sort by the joined key, joined condition. First sort, then match from the beginning. If match, yes, and next. If not, move next, and then you can find the matched one. So this one is called sort merge. So then, definitely, last one is as we learned, hash join. So hash join use, you can apply the hash function if the same value going to the same hash bucket. Okay? Then inside using brute force way, you can match them. But as we discussed before, if you apply the hash, the domain will be narrowed down. So modulo by 5 is a 20%. Modulo by 10 is a 10% reduce. So you can use the hash. But we are not going to count the hash. Also, sort merge depend on what? Sorting algorithm. First, we need to sort the data. And merge is simple. You can from top to bottom. It's one cycle. It depends on the number of complexity of the sort. The merge is n. However, sorting is totally different. So it depends on performance of the sorting. So we are not going to consider here, but in real, the DBMS, the sorting is critical. Then we are going to see the cost function for the J1 and J2, brute force, nested loop join, and the single loop join. To calculate the cost function, think about. First, you need to access number of blocks, left hand side, driving table. Okay? For each time you need to, so in case of brute force, you need to access number of blocks, driven table. For each B. So number of block BI times number of block BE. Basically. Okay? Basically, you need to access the BR times the BE. That is the reason. So, here's this. You can see, in case of nested loop join, so BI, first you need to access the BR, then access the BR times the BS. So BR, first access the driving table, then this is the driven table, inner table. How many times? BI times the BS. Okay? Then, if join, you are going to write the join data. Okay? So that is the join, the cost function. So basically, we don't know how many data are joined, right? If none of them are joined, satisfied with the join condition, we don't have to write anything, just return nothing. If everything is joined, it will be a lot of IO. So to calculate the such a join, we need to have another information. It's a join selectivity. Join selectivity means, so what is the percentile of the join with the data? So for example, employee, DNO is joined in the department DNO. How many? So for each employee, 1/125. So 125 will be joined. Right? Roughly that makes sense. But this is not a rough guess. So based on what? Real data. So the database administrator, keep updating what is the percentile of the join. Okay? In this case, 1/125, the case will be join. So this one will be also given. So this is the join selectivity. So using join selectivity, so number of record, the left hand side, the R, number of record, right hand side, and the join. How many times? Join selectivity. So it's 1/125 times R times S. That is the first Cartesian product. You remember join is the Cartesian product, then selectivity. Similarly, Cartesian product of the two of them, then 1/125. Join selectivity will be join. So this much of time we need to IO. So this is a should be block, so blocking factor will be applied. So this is the cost function of the nested loop join. So one more time, B number of block left hand side driving table, and the number of block times the number of block of the driven table is the BI times the BS. Okay. Then the plus in case of join. this one, the middle, in case of join. So this one, that is the R times S, and percentile is the join selectivity. And divided by the buffering factor, a blocking factor. So that is the number of ion. So what about the single loop join? It's the same as the nested loop join, but this one will be changing. So if you are using the secondary index, you can use the secondary index cost function. If you are using the clustering index, we can use the clustering index, the cost function. If you are using the primary, whatever the index, this part will be. So when you first access this, the B of R is will not be. We need to anyway access this. But for this part, so in case of the brute force nested loop join, it will be like the B times R times S. However, if we are using index, we can use the cost function of the such an index, depending on what kind of index is used here. Okay. And this is the same, the join case. Even though the hash is the vary. Okay. What about the sort merge? Sort merge is depend on the cost of the sorting, so cannot directly compare. So in our example, so we are going to use the nested loop join and the single loop join. So in this example, the same example, we have the 10,000 employee and the 2,000 block. Buffering factor is 5, and 125 record for the department, and the block is 13. Then we have the primary index department and manager social security. That is already catalog here. Okay, and so primary index for the DNO on the department, and secondary index for the manager social security number on the department, and also we have the join information, so like that. So join selectivity is 1/125. So this is the join employee. So employee join with the department with the join condition DNO is equal to D number. Okay, DNO of the employee, D number of the department. Then the blocking factor for the join is let's say the 4. At this time, we can imagine two types of join. So we have employee and department. So driving table for the employee, driven table of the department. At that time, we can use nested loop join and the single loop join, two cases. Also, department can be driving table, outer table, and employee will be inner table. It's a driven table. And also at that time, nested loop join, single loop join. So how many different cases? 4 different cases. So we need to calculate the 4 different cases. The first one is the employee is outer, okay, driving table. Employee is the outer, the driving table. Then the inner is the department. At this time, brute force, so 2,000 plus 2,000 times 13. This is a block, number of block. And the join selectivity is 1/125, and 10,000 times 125 divided by this is a join buffering factor is a 4. If you calculate, it's 3,500. And second option is we can use employee. This one, the department is outer loop. Okay, so this is the department, and the employee is inner. So 13, 2,000 times 13, and this is the same as this one. So you can see there's such a difference even. Which means, so when we access the data, everything is the same, but the order is different, and performance will be different. So you can realize this different performance. Then the third one, we can use the employee as an outer, but this time we are going to use a single loop join. So this is the index on the DNO. This is the index of the department table. Okay, so we can use the x plus 1 times this, so 10,000 times the 2. This is the cost function of the index. We can calculate. This is the same as the previous one. So 24,500. The last case, department is the driving table, and we use the index on DNO, on employee. So that is the x plus s, 2 plus 80, so 82. So if you calculate this one, it's total 12,763. So which one will be the lowest one? The last one is the lowest one. So which means the department outer and the employee is inner. Then we are going to use the DNO index, the secondary index of the employee. So execution plan is like that. Access the department and using, then access, there's an indentation because for each. So access the employee using, so what is the index number of DNO? It's a SI underscore DN. Okay, so this is the execution plan. So query process use this execution plan first to access the department for each department. Then you can find the matched one from the employee using SI underscore DNO. So this is the final output of the query process, the query optimization for the joined case. Okay, so wrap up. Query optimizer will count the number of items. Okay, so each case has their cost function. So they apply the cost function to find the lowest cost, the access path. Okay, at this time, there is a problem. What about if you have many index or conjunctive? You need to calculate all the cost, right? This example is a simple one. However, in general case, like the 3-4 table join, and where condition, selection condition is very huge, as we have seen before, 2,000, 3,000 different cases. You need to calculate all of this, right? Then to find only one, lowest one. It takes a long time, right? Even to calculate the cost. We try to save the time to access data, so we calculate the cost. But to calculate the cost, it takes a longer time, right? So like when you travel, so you spend a lot of time to make the plan, to find the lowest path, lowest fare. That's what usually we did, especially when we travel to overseas. When I even drive, because if I travel with my family, it's easily 10,000. Really. So because I cannot leave during the semester, so mostly peak time. So whenever I have traveled to my hometown, it's easily 10,000 more. So I try to find the cheapest one, but it takes time. So it doesn't make sense in this case. So DBMS, Query Optimizer, also apply some hybrid approach. Hybrid approach means many of cases obviously so doesn't save the time. So rule out the obviously the longer time, the query. So we will see the next class on Monday. So hybrid approach for the query optimization, then we will finalize. Then we will talk about the transaction management to keep the consistency of the data. Okay. So I'm going to update this one and make the PDF file and upload to the Canvas. Okay. Definitely, I'm going to use the 1 or 2 example of this for your final exam from the Query Optimizer. Okay. Okay, so we will see on Monday. We have class on Monday, okay?